Okay, this is a continuation of what we had just done in that previous one. All we're going to do here is we're going to see what that means. So now, if I were to just take a basic number line here, making this be all my positive numbers, this be all my negative numbers, this right here being my 0 point, what I've just found is the slope is positive here, and the slope is positive here. Now, what that means is the slope is increasing, or I'm sorry, the slope is always going this way here, the slope is always going this way here. In this case, we have a point that is called an inflection point. Right, this is going to be something where that slope is starting at very positive, becoming less and less and less and less positive, and then at the point of inflection, from going to 0 temporarily, that slope is then going to start positive and get more and more and more and more positive. Okay, now for our uses, this is not going to be too insanely useful. For the stuff that we're going to be talking about, not incredibly worthwhile, but we will get to the point where it is useful later on down the road. In the next video lesson, we're going to talk about the second derivative test, and in that's where this stuff actually gets a little bit more important. Now, when we're talking about relative extrema, maximum, minimum, a maximum is always going to happen when it is positive leading up to and then negative going away from. A minimum, I'm just going to call it minima here just because I'm lazy and don't want to keep writing, means that you're going to have a negative going to it and a positive coming away from it. Okay? Now, we'll talk about concavity and stuff like that as well in the next video lesson. But in this case right here, we don't have that. We have what's called a point of inflection. That is either positive going to positive or negative going to negative. In this case here, it is not changing the direction, it is just changing the overall speed. So this may be the only point that is actually of interest in these situations, but hey, thus is life. Okay? Now, let's do one that's actually going to have a relative maxima or a relative minima. Let's go, use the vector r this time just for fun. R equals 2t squared. Let's go minus 2t. We'll put that all in the j hat direction. Okay, now one thing that I have not really harped on yet, but I do want you to notice, is that in this case here, notice that I put parentheses inside of here to show that all of this has to do with the j hat direction. Okay, so if I were to take the derivative of r with respect to t, it would be 4t squared minus 2. Okay, that is still all in the j hat direction, and I've just figured out what the slope is from negative infinity to infinity. All right, now let's figure out what our important points are here. So to do that, we're going to set this equal to 0. 4t squared minus 2 equals 0. Alright, so 4t squared, add 2 to both sides, equals 2. Divide both sides by 4, divide both sides by 4. T squared equals 0.5. Now I'm going to use the aid of my handy dandy calculator here to get this figured out. So I've never actually done the square root of 0.5 in my head. 0.707. For some reason I feel like I should have known that. 0.707. I think that's probably some tangent or something way back in the day that I had to deal with. Alright, so 0.707. So what that means is at that exact point, the time is 0. Okay? So I'm going to have to pick 2 test points. One that's greater than, one that's less than. Well, I got one really good less than one. 0. 0 makes my life easier. So my 2 test points I'm going to use are 0 and 1's greater than it. So I'll use 0 and 1. So 4 times 0 squared minus 2 equals some number, negative 2. Negative 2, the sign is negative, so therefore we have a negative slope for all t when t is less than or equal to, well, we're not going to worry about equal to, for all t is less than 0.707. Alright, so then we'll try 1 over here. For 1 squared minus 2, 4 minus 2 is 2, which is positive, telling us we have a positive slope here. Right now, without doing any graphing work whatsoever, I'm able to determine what's going on here. I know that my point of interest is at 0.707. I know that every point before that on a number line is going to have a negative slope. Any point beyond that on the number line is going to have a positive slope. So in other words, negative, 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 positive, 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 positive. In this case here, I have what is called a rel min. Okay? Now, we're going to talk further about this as well as the second derivative test on the next video lesson. I will give you a couple of practice problems that I want you to try to just get the basic values for. Look on the assignments tab for those couple of practice problems. The answers will be immediately beneath them. Good luck and see how it goes.